This is lesson 10-2. We're going to take a look at common types of sequences. And so we're going to determine if the sequence is arithmetic or geometric. So here is the definition of a geometric and arithmetic sequence. Now remember, this is the notation that we introduced yesterday. So we're just saying that that phrase or that symbology is going to be the sequence, and we're defining it as that sequence. And so for the arithmetic, it says if there is a number d that in our sequence, whatever my term is, I'm adding or subtracting, we're just going, because d could be positive or negative, a number every single time, then we call it an arithmetic sequence. And we call that value d the common difference, d for difference. So the way that we identify this, are we adding or subtracting the same number every single term? So adding or subtracting the same number every single term. And then for geometric, if there is a number r, so that we have this r times a sub n for all values, then we're going to call it a geometric sequence. And we call this value r a common ratio. So in this one, are we multiplying? And I guess if you want to look at a fraction as division, but technically dividing by 3 is the same as multiplying by 1/3, right? So if you want to look at it that way, that's okay. But in this one, the idea is, are we multiplying a value every single term? Okay, so that's it has to be the same value. And so that's the way that we can identify them. So the arithmetic sequence, are we adding or subtracting the same value? With the geometric sequence, are we multiplying by the same value every term? So let's look at this first one. Let's determine if the following is arithmetic, geometric, or neither. So what we do is, there's actually a couple of ways that we can go about this, but what we can go through is we can actually just find a few values in the sequence and then check to see, is it increasing by the same value every time? So for example, if I plug in 1, I get 5 to the 0 over 3 to the first. So I get 1/3. So that's my first value. And then if I plug in 2, I'm going to get 5 to the first over 3 squared. So that's going to give me 5 over 9. Then if I plug in 3, so here is where n equals 1, n equals 2, just so we can keep track of it. So if I plug in 3, so I'm going to get 5 squared over, and it looks like 3 to the third. So that's going to give me 25 over 27. So now I kind of have enough terms. If you guys are still a little uncomfortable with how many, you can always plug in a fourth. But now all I need to do is just take a look at this and determine, okay, starting from here, how is it going up by? Well, it looks like I'm multiplying by 5/3. And then taking a look at this one, it looks like I'm multiplying by 5 over 3, because 5 times 5 is 25. 3 times 9 gives me 27. So it looks like I'm multiplying by 5/3 every single time. So if I wanted to try n equals 4, I'm going to get 5 to the third, because 4 minus 1 over, and then 3 to the fourth. So that's going to give me 125 over 81. Okay, once again, multiply by 5/3. So another way that we can check this is you can actually just take the values and divide them. And if you get, when you divide them, if you get the same value every single time, which should be 5/3, if you don't get that same value every single time, then you also know it's going to be, in this case, geometric, because I'm multiplying by the same value every time. So I know that this sequence is geometric. So for this one here, determine if it's arithmetic, geometric, or neither. So once again, let's establish a pattern. Let's plug in values for 0. So I get -1. This is for k equals 0. So I get -1 to the 0 over 2 times 0 plus 1. So that's going to give me, well, -1 to the 0 is 1. So 1 over 1, so I get 1. Now let's look at k equals 1. So I get -1 to the first over 2 times 1, which is 2, plus 1. So that's going to give me -1 third. Okay, still not enough of a pattern. Now let's try k equals 2. So I'm going to get -1 squared over 2 times 2 plus 1. So -1 squared, -1 times -1 is +1. 2 times 2 is 4. 4 plus 1 is 5. Okay, that's weird. Let's try k equals 3. So I'm going to get -1 to the third over 2 times 3, which is 6. So that's going to be -1 over 7. Okay, so I think this is enough to kind of see if there's a pattern that's being established. So first of all, for me to get from 1 to -1 third, I'm going to have to multiply by -1 third. But if I multiply by -1 third again, that does not give me 1/5. So it can't be geometric. It has to be multiplied by the same value every time. Now if I were to add, let's say if I were to add 2/3, well, if I add 2/3 again, that doesn't give me 1/5. And then if I add 2/3 again, that doesn't give me -1/7. So there is no common difference. There is no common ratio. So therefore it's neither. All right, so we're going to practice a few. So go ahead and pause the video and go ahead and try this one out. All right, so let's check this one. So if I plug in n equals 1, I'm just going to do this one quickly in my head. So 2 times 1 is 2, 2 minus 1 is 1. Plug in 2, you're going to get 3. Plug in 3, 6 minus 1 is 5. Plug in, so there's 1, 2, 3. Plug in 4, so 8. 8 minus 1 is 7. So if you notice, I'm going plus 2 every single time. I'm adding 2 every single time. So that's going to be arithmetic. That is an arithmetic sequence. Now this one right here. Go ahead and pause the video and try and check this one out. Alrighty. Going over this one. So for this one right here, it seems like a way for me to get there is I multiplied the top by 3 and the bottom by 2 and then a negative. So I multiplied by -3/2. Well, let's see if I multiply by -3/2 again. So if I multiply the top by 3, I get 9. If I multiply the bottom by 2, so 4 times 2 is 8. Negative is a positive. Hey, look, I got that one. All right, let's try it again. Multiply by -3/2. So it looks like -3/2 worked. So let's try -3/2 again. So 9 times 3 is 27. 8 times 2 is 16. Multiply by negative, I get -27 over 16. So this is geometric. Alrighty, so concluding today's lesson, we took a look at an arithmetic and geometric sequence. And the main difference between the two is with an arithmetic sequence, we are adding by the same value every single time. In a geometric sequence, we are multiplying by the same value every time. Now, like I said, it just depends on how we want to think about it. In arithmetic, you can add a negative number every single time. So adding or subtracting, right? And just like geometric, multiplying by 1/3 is the same as dividing by 3. Okay, so just be careful with that. But with arithmetic, adding by the same value, geometric, or multiplying by the same value every time. This does conclude our lesson. If you have any other questions, please leave them in the comments.